Hi, everyone. Welcome to this special Xoogler meetup. We're so glad to hear from Teddy Lee. Teddy was actually a Googler in 2013 and 2015 in the New York office, and he's now a PM at OpenAI. As you can imagine, OpenAI is one of the hottest companies producing a lot of amazing products and technology that's world-changing right now. And when I reached out to him on LinkedIn, he immediately said yes and wanted to help educate all of us. As you can see, probably from his background I shared before, he also gives back to his alumni associations, whether it's MIT as well as Stanford. And he'll talk more about his background and how he ended up at OpenAI. He'll go through his specific topics, and we'll probably leave the last few minutes for open questions. So feel free to start putting it on the chat, and I can moderate the discussion. But further ado, thank you, Teddy, for joining the Xoogler community here today. Over to you.
Thank you, Chris. It's an honor to be here. I have very fond memories from my time at Google, so it's really very cool for me to try to share some of my knowledge and get to know members of the Xoogler community. So let me share my screen. So my talk today will be, can you all see these slides? Great. All right, so my talk today will be focused on accelerating model development with human in the loop. So by way of a bit more introduction, I, as Chris mentioned, used to work at Google. I was in the New York office from 2013 to 2015. Those were some of the best memories from my working life that I can think of. This photo on the left, actually, I realized as I was putting this together, was taken at the wedding of a Google colleague, a good friend that I made while I was at Google. So again, really happy to be here. I've also worked at McKinsey in strategy roles, as well as right before OpenAI, working at Scale. Scale AI is a company that does data enrichment for AI applications. And I was actually serving OpenAI for my 2 years at Scale. And I got really excited about what the team at OpenAI was doing. And so I joined OpenAI in May of last year. As Chris mentioned, I'm also quite involved outside of work in the MIT Alumni Club. I'm the current president of the MIT Club of Northern California, and I'm also a member of the Alumni Association board for MIT. And I actually got into the AI space through that. I was the chair for the MIT AI conference back in 2019 and 2020, and that opened up the horizons for me as far as AI. So in terms of what I want to go through with you all today, I'm going to tell you a bit about what we're trying to do at OpenAI. What is the overall mission? I'll talk about the ingredients for powerful AI systems such as AGI. We'll walk through a few case studies on human data. I'll zoom in more on the data piece of this. That's really my focus and my expertise. Tell you a bit about some of the metrics that we think about when we think about ensuring that we have high quality data to train our models. And I'll leave a good amount of time at the end for a Q&A, and I know Chris has already collected some questions from the audience, but definitely we'll take questions live as well. So what are we trying to do at OpenAI? Most folks probably know OpenAI for ChatGPT or DALL-E, but the mission, which is what really drew me to the company, is to create artificial general intelligence that benefits all of humanity. By artificial general intelligence, we mean AI systems that are generally smarter than, as smart as, or smarter than humans and able to do most things that humans can do. And the hope is that this will unlock a lot of economic potential and make it so that humans can focus on things that they really love doing while kind of outsourcing a lot of things that are not so enjoyable, and that we can allow a lot more people to get access to things like healthcare and education, and general capabilities. So I'll talk a bit more about that later on in terms of some of the use cases. I think there were some questions on that. So how do we actually go about building AGI? So the ingredients for AGI, or highly capable models, is there are three things. One is algorithms, the second is compute, and the third is data. So on the algorithms front, that's new algorithms and architectures, and that's typically what AI researchers are focused on developing. And an example of this is proximal policy optimization, or PPO, which is a type of reinforcement learning that was developed at OpenAI and is used in things like reinforcement learning for human feedback, if folks are familiar with that. The second pillar is compute. So you probably know that GPUs are very in demand right now. NVIDIA's stock price has gone up a lot in the past few months and years because a lot of these companies that are building large language models need a lot of GPUs to train for training and inference for these large language models. And the third pillar is data. So again, this is what I'm most focused on. And this can be broken down, broadly speaking, into pre-training data and fine-tuning data. So pre-training data is the publicly available internet data that OpenAI and other companies developing large language models have trained on. So this is typically pretty unstructured, and there's some kind of filtering of content, but it's really kind of throwing everything in the kitchen sink into the model. And then how do you get the model to really perform well and perform in accordance with what humans want? That's the fine-tuning part. And I'll go into some examples of this. But that's what I'm focused on. So not so much for me the pre-training side, but more on the fine-tuning side, which really is kind of, I think of as the last mile part of model development. How do you make it not just really smart, but really fine-tuned and capable? One thing to call out, a lot of people look at companies like OpenAI or Google that are developing these models and think, oh, who has, the best? Somebody must have innovated from GPT-3 to 4 with some amazing breakthrough on an algorithm or something like that. But really, one thing that I want to emphasize is that it's all three of these things multiplied together. So a lot of small incremental improvements on each of these three pillars that drives a lot of what looks like step changes in the performance of these large language models. So again, for me, it's really the data piece, and this is an area that OpenAI has really leaned into in the past few years. I think we have known for a long time that algorithms are important. That's why these AI researchers are so in demand. We also know that compute is very important. That's why people are buying so many GPUs. But more recently, people are realizing that data is the third pillar that really needs to be improved and needs to be a strength for these companies developing AI systems in order to make those AI systems really performant. So I'll go through a few case studies here to make it a little more concrete what we're talking about when we talk about human data. So DALL-E is a AI system that we released that allows you to generate really compelling images with words. You can write a caption. In this case, it's kind of like a astronaut on the moon riding a horse on the moon or something like that. And then DALL-E will generate images. Many of you have probably tried it. There's many other players in the space as well. Our goal with DALL-E is to empower people to express themselves creatively. And we strive to do this with human data. For example, we are using labeling images with captions in order to create more accurate generations. So that when you say astronaut on a horse, it doesn't spit out astronaut sitting on a cow or something like that. It's because there's some kind of labeling of the data for horses versus cows. We also are trying to make these images more compelling. And a lot of that is a matter of aesthetics and a matter of human judgment. But that is another way that we gather human input, showing two generations of an astronaut on a horse and asking the people looking at them to evaluate them on aesthetics, on color, on shading, all kinds of different dimensions that we might care about for what makes one image look better than another. And we also use human data, human expertise to help us categorize images that are flagged if they are in violation of certain content policies. And the idea is always to train the model to itself detect when that might be what's being asked for, what's being generated, things that we wouldn't want generated. But there is an element of getting people to come in and provide their judgments on things that might be against policies. The next product I'll talk about where we leverage human data is Codex, which is also what's underlying plugins for those of you that are familiar with that release from OpenAI. So with Codex, our goal is to enable computers to better understand people's intent, which can empower everyone to do more with computers. Essentially, Codex is what's underlying GitHub Copilot and allows software engineers to write code much more quickly and accurately. It's kind of like an autocomplete for code. So in this case, we also use human data to generate more useful code, more robust code, and more accurate outputs. More useful code by having coders, people who are experts on coding competitions, come in and write their ideal solutions and provide comments on those pieces of code. We also have experts demonstrate unit test creation so that we can create more robust code. We can teach the models to write tests and check their own work, just like a software engineer would. And then on the plugin side, there's one of the things that plugins enables is browsing and fact checking. And that's something that allows us to generate more accurate outputs if the model can detect when it should go and search for the latest and greatest information and incorporate that into its answers rather than just going with what it already knows. The third case study is ChatGPT. With ChatGPT, our goal is to make a chatbot that is helpful, that is honest, and that is harmless. And these three things, by the way, are often in tension, but how we use human data to try to strive for these three ideals is that we get humans to provide preference ratings on outputs, say A is better than completion A is better than completion C, which is the same as D, which is better than B. So the model can generate different outputs, and then humans can tell it which ones are preferred. We can also have humans tag specific errors. This is factually incorrect. This is redundant. This is a grammatical error, to make the models output things that are more honest, more consistent with reality or with certain rules. And finally, we also have humans give demonstrations of more nuanced responses to unsafe requests. So something that we've developed is the concept of safe mode or refusal. So we don't just want the model to refuse to answer prompts that might be more sensitive. We might want it to answer, but in a more natural, nuanced way that kind of diverts the conversation or provides an answer that is still helpful, but not quite what the default would be if you didn't fine tune it. And the fourth one is more of a preview, something that my team is working on now. We are working on democratic inputs to AI. So a lot of the things that humans will always need to provide for these models, even as they become super intelligent, even as they become more and more accurate with fewer hallucinations, human preferences and human values will always be something that humans alone can provide. And so one of the things that we're exploring is how do we develop a democratic process for aligning AI behavior so that as models become more powerful and as they become more powerful, we want to be able to steer them and take input from the outside world and not just have a group of people who work at OpenAI or a very limited biased group providing those human values and preferences. And again, this is a relatively new effort. We did start a grant application process, and we're partnering. Actually, I'll go in the order of the bullets. First one, we're building and testing prototypes ourselves. We're also exploring ways that large language models can actually enhance democratic processes. So there are ways in which you can use large language models to represent certain perspectives and make sure that we can consolidate and synthesize different arguments, even with a lot of different people chiming in. We can also use large language models or even just kind of things like Polis, which is a platform that allows for surfacing of hot, kind of like the Dories that we used to have at Google. People can kind of submit statements and other people can upvote them or downvote them. These are ways in which we can use technology and hopefully large language models specifically to actually enhance democratic processes versus just kind of not making things worse, actually use it to make things even better and really take advantage of the strengths of technology and the ability to bring a lot of voices into the conversation and still have productive democratic deliberation. And then finally, I mentioned briefly that we had a grant application process recently. We know that there's a lot we don't know. We know that there's a lot of people out there, teams, companies, nonprofits working on this very question and have been working on it for a long time and know things that we don't know. And so we're also partnering with these external stakeholders, thought leaders and builders to enable them and learn from them and collaborate with them to build this system. Okay, so getting into a bit of the nitty gritty on human data. One of the ways that I like thinking about this is actually from Andrew Ng. So he compares data to food, food for AI. And the reality is that today, a lot of the time and effort is spent on AI research. So really the architectures and algorithms pillar, and relatively little is actually spent on the actual data piece. And in the same way that if you're trying to cook a really great meal, you actually want to spend 80% of the time prepping your ingredients, and then 20% of the time, a minority of the time, cooking the ingredients. So in the same way, when you're trying to build a powerful, effective machine learning model, you want to spend 80% of your time actually sourcing and preparing high quality ingredients, and only 20% of your time and 20% of your resources potentially actually training the model. So the idea here is there are these two ways that you can drive model improvements. Obviously, compute is a third pillar, but more compute is better. But between these two, relatively too little effort is spent on ensuring that the data is of high quality. And another way that he frames this is that you can take a model-centric view, or you can take a data-centric view. With a model-centric view, which is the typical view, if you will, the idea is that you work with the data you have, you just hire some really good and frankly, very highly paid AI researchers, and you have them build a very robust, effective model. And you just throw that crappy data in there and it'll figure it out anyways, because the model is just so powerful. You hold the data fixed and you just improve the model. The other view is the data-centric view. You can actually do more with tools and process and operations to improve your data quality, such that you actually don't need the world's best model, where you've hired some really skilled AI researchers to work many hours to make that model super robust, because you've actually made the data really high quality. And so the model actually can be very performant, even if it's not the best model. And obviously, if you have a really great model and really good data, then the best of both worlds. And again, you get that multiplicative effect. So the idea is to think of at least not just a model-centric view, but also a data-centric view. And then I'll talk more about some of the tools and processes that you can use to actually improve the data. And again, it's not necessarily either or, but just know that focusing only on improving the model is not necessarily going to yield the most fruit. You need to also focus on the data. So what are the metrics that matter for data? There are two: quality and throughput. Basically, quality is paramount. So if you put garbage data into your model, just like if you give a kid some completely wrong textbooks with talking about how the earth is flat or whatnot, the kid's going to come out knowing a bunch of stuff that doesn't match reality. Furthermore, when you talk about quality, it's very easy to say we want high quality, we want 99% accuracy. It's quite important to take some extra time and work with your researchers to figure out what exactly do you mean by quality? What are the model performance metrics, and what are the data quality metrics that you really care about? Is it really 99% precision you need, or is it really just 95%? Do you actually care more about recall or precision? Maybe it's some other metric altogether. Really defining how are you measuring quality, and not just hand waving it, say, let's hire better experts and quality will be better. You want to actually define quantitatively what do you mean when you say high quality, and how does that tie to model performance? And by defining that, you can actually measure it and drive improvements towards it. And of course, you want to always measure quality, tie it to the actual model performance, adjust those measurements, and then repeat. For throughput, this is the other dimension. So you can have really high quality data. In some cases, you have a really smart model, you just want really high quality data. You don't actually need that much data. In other cases, you might just want a sheer quantity of data. There's kind of like a trade-off that you might be able to calculate. So it's worth doing some studies on that. But ultimately, there's always some minimum amount of data that you probably need, and more data of the same quality will be better. But in general, I would start with quality, define what quality means, figure out what quality you actually need to achieve and how to achieve it, and then start to ramp quantity. Don't try to ramp quality and quantity at the same time. You're probably going to have crappy quality, and then even if you scale it up, having a lot of bad quality data isn't really going to be that useful. For throughput, eventually you can also increase the number of people doing the work. You can also make some improvements to the UI, or select the tasks more strategically for things that you are, let's say you're doing self-driving cars, you have fewer examples of foggy scenes and you need more of those. If you just find more of those and have people improve the quantity of data for that, that might be good as well. So with throughput, basically you can increase this via more headcount or by making people more efficient in doing the tasks. And same third bullet as the previous point, throughput is also something where you can actually do studies to see, when we have 1,000 pieces of data at a certain level of quality, the model performance increased this much. When we add another 1,000, increased by this much, or more likely 10x that, how much does the actual model performance change? So it's worth graphing that and figuring out exactly what the relative improvements look like based on additional throughput. So how do you actually manage quality? There are three pillars: instructions, metrics, and audits. So when it comes to instructions, you want to really write down very precisely what exactly it is that you need your AI trainers, your data labelers to do. And it's really important to have a single source of truth that everyone follows. It's very easy to have misalignments with AI researchers. And then when you're really trying to scale things up and everyone has a different definition of how big the bounding box should be, or what it means for something to be beyond a certain threshold of sensitivity, it's going to become very messy in terms of your data quality. Metrics, we talked about that already. You want to define metrics very precisely. You want to make sure they actually tie to model performance metrics. And you want to measure that on an ongoing basis, set targets, adjust them based on the relative improvements you're seeing in your model. And you want to track this over time. Hopefully, with the operations side of this, you can see improvements over time and figure out if things are not where you want them to be. Deep dive into why that might be. Is there a certain category of labels that are not so accurate? Is that because the instructions aren't good? Is it because something about that category is underspecified? And then finally, there is a very important component of auditing. So I think that oftentimes people think that data, human data, is kind of just like compute, just like you define your specifications and you just scale it up. But at the end of the day, if there are people doing the work, it is important to continually audit. Sometimes there are new people added and they may learn the rules differently or understand them differently. You may see that the data itself has changed. All of a sudden you have a new category of, let's say people are labeling ChatGPT, and all of a sudden you get a bunch of people asking questions in a different language. And then all of your people who are doing the enrichment are using Google Translate, and that's resulting in some misunderstandings. That's something you want to really figure out by auditing the data and seeing if the data itself has changed or if people are labeling things differently than they used to. On the throughput side, the other metric that matters, a few things to think about. One is task design. Second is specializing your trainers. And third is metrics and incentives. So a simple thing to do when you design a task is just to actually do the task yourself. Have the AI researchers do the task themselves, follow the instructions, have someone who's never done the task before, have another AI researcher not involved in the project, or have another colleague, just somebody who has no context, do the task and see if they can actually do it effectively. Do the instructions contain all the information they need to do it right? Are there questions that they have that are not answered, which everyone else already knows the answer to because they have context? Are there ways to break the task into smaller, more modular tasks? Can you create visual aids like decision trees? Can you add tooltips in the UI? Can you create some linters to automatically detect when there's, two choices made that could never really be true? Maybe it cannot be both foggy and a truck. You just know that all the foggy scenes were collected in an area where there were no trucks. So if you detect inconsistencies there, maybe you can catch some kind of errors that could deteriorate the quality of your data. Second one is trainer specialization. So with ChatGPT, we have people that look at things that get thumbs down labels. And if you just throw even some really smart people, some Googlers, at a bunch of things that are not in their native language or that are legal questions or medical questions, you're probably not going to get great results. You want to align the tasks to people who are specialized to do those tasks. You also want to think about how you create layers of reviewers and attempters so that you can have kind of checks and balances. You want to provide feedback to people that are doing the work so that they can actually improve. And then you want to make sure that you keep track on a person level, kind of who's doing good work so that you can potentially put those people into positions of review so that they can actually review work rather than do work. And that's a higher leverage way of them spending their time. And then finally, setting metrics. So again, you want to quantify time per task, figure out, are there certain tasks that are taking longer? Why? Can we break those tasks down if it's because the tasks are too long? You want to set goals for your team. Usually you want to start with how many pieces of data are we trying to get to over what period of time? And then you can work backwards from there to figure out how many people you need based on how long it takes each person to do those tasks. And of course, you can also offer incentives for people to hit certain throughput goals. But obviously, if you have higher throughput or you're incentivizing higher throughput, you may see quality deteriorate. So these two are kind of often things that you want to strike a balance between. Okay, so in summary, model capabilities are a function of your algorithms, compute, and your data. It's not just one of these things. It's not just about throwing more GPUs or hiring more AI researchers or getting higher quality data. You really want to push on all three of these fronts. Historically, the first two, architectures and algorithms, as well as compute, have been more of the focus, but increasingly people are seeing that by adding in high quality data and really expert people to fine tune your models, you can get superior performance. We're looking ahead to humans providing their preferences on more value-laden questions and not just on more objective things, because we think that that's going to become more and more important as these models become more powerful and more widely used. We talked about the idea of taking a model-centric view versus a data-centric view, and the idea that both are important, but maybe you want to try both instead of just pushing on one. And finally, we talked about the metrics that matter. So at a high level, we've got quality and throughput, and then you can improve quality by writing really high quality instructions, by setting metrics and measuring quality over time and diagnosing when those metrics aren't being hit. A little typo here. And of course, also doing audits on an ongoing basis, not just at the beginning, not just at the end, but throughout, so that you can keep improving. And then for throughput, you want to make sure you design your task properly, that you watch people doing the task and see where they're getting tripped up or what kind of questions come up, by specializing people to the work that needs to be done, and by setting target metrics and providing incentives and putting more experienced people in positions where they're reviewing things rather than doing the task from scratch, so that you're making the best use of your people. All right, that's all I've got. Thank you.